screen and start letting people in if you guys are ready for me to do that.
Yeah, ready to go.
All right, great. How about you, Drew? You ready?
Fine by me.
All right, perfect. Here we go. Welcome, Laura. Glad you're here. Nice to see you. Welcome, Diana. Welcome, Laura. Just getting a few things set up here with my thing here. If you're just joining us, welcome, welcome. Feel free to introduce yourself in the chat. We'd love to know where you're calling from, and if you want to mention anything that you're looking forward to learning tonight, that would be great as well. And we're just going to get started at the top of the hour. So let me just get my screen sharing going here again, and we will get rolling. Really glad to have you on, everybody who's here. We are here for the Science and Climate Misinformation AMA, Ask Me Anything with Dr. Drew Shindell. So really happy to have you this evening. Let me go full screen here. Here we go. There we are. Somebody can give me a Yahoo or a yes in the chat just to make sure that you guys are seeing that big blue screen. Not the blue screen of death, just the welcome blue screen. That would be wonderful. New member, San Antonio, Texas. Welcome, Laura. Great to have you here. And we are rolling here. And we are just going to get started at the top of the hour if you're just joining us. Super nice to have you here. Feel free to introduce yourself in the chat. You can start posing your questions at pollev.com/CCL123, which I will drop into the chat right now. We are going to be taking questions from there, so feel free to drop the questions in there when you have them. You can also check out Dr. Shindell's website in the meantime while you're waiting, if you would like to, or the Skeptical Science website. And like I said, if you haven't had a chance, you can feel free to introduce yourself in the chat. Be great to know where you're calling in from if you haven't let us know that already. I am just getting my screen set up. Welcome, Miranda. Welcome, Rob. Nice to have you here this evening. Thanks for joining us. And if you would like to follow us online, we have Facebook, we have Twitter, we have Instagram, and we even have TikTok. TikTok. Love saying TikTok. And as I've said, you can share in the chat where you're calling from. And here is the online training, if that is helpful for you. We have a climate science basics training on CCL community for you to reference at any time. And that way you can take this content at your own pace as you would like to do that. If you are interested in being on video tonight, we would love to see your face, of course, but there's no pressure. It's just nice to be able to present to people's faces when possible. For those of us that like to teach, I'm guessing that Drew's a professor, so I'm guessing he also likes to present to a room full of faces. If you are able to be on video this evening, that would be awesome. And we're just going to get started in 1 minute at the top of the hour. Thank you everybody for being here. If you've just joined us, feel free to introduce yourself in the chat. Let us know where you're calling in from. And feel free to follow us online, Facebook, Twitter, Instagram. And we are going to get rolling in just right now, actually. It is time. Welcome, welcome, welcome to tonight's Science and Climate Misinformation. Ask Me Anything with Dr. Drew Shindell and Dana Nucitelli. And it is my pleasure to be able to welcome you this evening to this webinar. My name is Tamara Staten. I am CCL's Education and Resilience Coordinator, and it is wonderful to have you here this evening with us. So just a few points of housekeeping. This training is being recorded as well as live streamed actually on YouTube, and is available on CCL Community simply by typing in the title into the search bar on CCL Community. There will be time for Q&A after a short presentation, so you can start posing your questions at our online question, pollev.com/CCL123. All lines are muted. I'm going to do that right now, actually. So Drew and Dana, be sure to unmute yourselves before you talk. And if you have any tech needs, we're going to be so busy doing a bunch of science stuff. Please check out the support at Zoom if you have any support needs. I dropped that link in the chat, or you can call 888-799-9666, a phone number that I will also add to the chat for you. I do want to first mention that our MC this evening is Dana Nucitelli, and he is an environmental scientist, a climate journalist, and author of Climatology versus Pseudoscience. He has published 10 papers, perhaps even more by now, related to climate change in peer-reviewed journals, including 3 studies on the expert climate consensus. He has written about climate science for skepticalscience.com since 2010, for The Guardian since 2013, and Yale Climate Connection since 2018. And now I'm pleased to be able to introduce you to our primary speaker this evening, Dr. Drew Shindell. He is a Nicholas Professor of Earth Science at Duke University. From 1995 to 2014, he was at NASA Goddard Institute for Space Studies in New York City and taught at Columbia University. He earned his bachelor's at UC Berkeley and his PhD at Stony Brook University, both in physics. He studies climate change, air quality, and links between science and policy. His research group is particularly focused on quantifying the impacts on human health, agricultural yields, climate, and the economy of policies that might be put into place to mitigate climate change or improve air quality. He also continues to pursue studies of how regional climate responds to changes in radiative forcing by different agents and in different locations. He's been the author of over 200 peer-reviewed publications, received awards from Scientific American, NASA, NSF, EPA, and is a fellow of AGU and AAAS. He testified on climate issues before both houses of the US Congress at the request of both parties, and developed a climate change course with the American Museum of Natural History. So without further ado, Dr. Drew Shindell, I'm going to stop my share. You can say hello by waving, and you can take it away. I believe Dr. Shindell has some slides to share with you, if not a few words before that.
Yeah, hi, everybody. I'm follow the precedent here in the chat. I'm calling in from Durham, North Carolina, where Duke is located. And I'm happy to talk today. Actually, I'm much more interested in the question and answer. So I'm going to try not to talk too long, but I wanted to tell you a little bit about some of the things that we've been working on in my research group with my students and postdocs and others, and some of the things that I'm excited about for some of our new results that might be of use to you as well, to the Citizens Climate Lobby in general. So I'm going to share my screen with you and tell you a little bit more, kind of following up here from what Tamara was just saying about the kind of things that we work on in my group. We try to look at climate and a lot of the impacts of climate. One of the real goals I have is, I've been, you can see from the white hair, at least what's left of it, that I've been in this field for a long time. I've spent a long time talking to people about climate, and the reaction is, they're committed folks like yourselves, but there's lots of people who just say, oh, this is a far off problem and it's a lot of hassle, and who cares about a couple tenths of a degree anyway. So a lot of the work that I do is focused on trying to tell people why this really matters in a way that they can relate to. And that's pretty hard with climate for many reasons, not least of which that, people don't necessarily understand why 3 degrees is so different than 2 or 4 or any of the others. But another thing is the time that it takes for climate change to happen. So this is a chart here on the screen that is from the last IPCC report. The next one will come out next week, I believe. So this will soon be kind of out a little bit old. But the point here is that when we wrote this report in 2013, we had scenarios where we looked at kind of different futures that we might have, and they diverged in 2005. And I've labeled them up here. We have about a 2-degree future, or a couple around 3, and one close to 5. And what you can see is that the temperature of the planet, if you wait, say again, they diverge around 2005. So around 15 to 25 years later, you can kind of still hardly tell the difference between these scenarios, right? 2 and 3, you can't really tell apart at all, right? And the 5, not really very different from the others either. And by the time you get way out towards the end here, about 45 years into the future, okay, you can start to see some of the difference, at least for the top one, the really warm scenario, but you still can't tell the others apart. So some of the things that I think are really challenging in convincing people, climate is really important. Right now, we have to take action. Oh, and by the way, you won't see much benefit of that action, maybe even for much of the rest of your life. Not an easy message to convey to people. So along the way, my thinking about this has been, how do we deal with the time problem? And how do we deal with the problem that, even if I look at a graph like this, to most people, okay, well, what's the difference between 1.7 degrees in 2050 versus 1.4? It doesn't sound like much. So I've tried to quantify things people might care about. And one of those is shown here. I've been pleased about the uptake of some of our latest calculations. This is from a paper we wrote last year, but the screenshot I've captured here is from a kind of visual op-ed that some folks wrote and ran in the New York Times just a couple of weeks ago. And what they talked about was, especially with all the heat-related deaths in the Pacific Northwest over the past couple of months, how this could really become a very serious issue. Using all the results from our paper. So we have state level results for the likely effects of heat on premature death, heat actually killing people. This is per million people, and we have a scenario where there's some adaptation and some with no adaptation along the bottom. But the point is, we have huge differences between business as usual, modest emission reductions, or really aggressive reductions. And so this is kind of the answer to the question of, what does it mean if we're aiming for 5 versus 3 versus 2? And it means a lot fewer people dying from heat, for example. But if you look here at the date here, what they've chosen to show is the very end of the century. So we still have the time problem. And so again, this is from a paper from last year. We have a new paper, which is in the last, it seems to be a very lengthy process, but the last stage is a very long peer review process. And I hope it will be out next month or so. And I want to show you a few of the results from that paper. We're just down to the last details about the presentation. So none of the quantitative results will change at this point. And what we've really tried to do is take advantage of the fact that if you're going to aggressively mitigate climate change, you're going to stop a lot of things that lead to air pollution. You're going to stop burning fossil fuels in cars. You're going to stop a lot of pollution from industry. You're going to stop a lot of practices that lead to both particulate and ozone precursors. And this is one way to deal with the time problem, right? If you start to phase out fossil fuels and move towards, say, clean electricity this decade, indeed, you might not see a benefit in terms of climate for several decades, but you will see a benefit in terms of public health instantly, right? Just look at last year with COVID, right? The pandemic caused lots of things to shut down. Climate didn't change at all. And yet we saw the air get cleaner, especially in places where it's really easy to see because it was dirty to begin with, like China and India, right? So pollution responds really quickly. So that's what we've tried to do. I won't go through a lot of details, but in preparation for the upcoming IPCC assessment, we'd already run the NASA climate model. And what we did was just add a few little things to it, to have higher resolution air pollution data and high temporal resolution surface air temperature, so we could look at the effects of things like heat waves, right? It's not a monthly average that's hot, it's a few days. So here are some of the things we found. On the left now we have 2030. So we have by the end of the first decade of action. This is taking action starting now, 2021. And on the right, we have 2070. And so what we've done is tried to quantify for every state in the Union, other than Alaska and Hawaii, every state in the contiguous US, what the number of avoided deaths would be due to different environmental exposures. And so this first one is particulate matter. You can see, for example, 4,000 fewer deaths in Texas by the end of this decade, right? So this is a really fast response. You've got 8,000 in California out in the future, but you also get nearly that much. You get 6,000 by the end of the decade. This is the same thing, but for ozone. Tends to not kill as many people in most of the country, but it can be quite important in some states with high levels of ozone pollution. Again, a very large response by the end of the first decade, by 2030. And similarly, some states have even larger responses in 2070, some have weaker, but we've got all of the numbers for all of the decades going out for both of these quantities. This one is heat, right? And you'll notice maybe two things here. One is if you were following the color scale, it's not as dark over many of the states with very high population levels. Places like California and Texas with large populations and big cities, that tends to concentrate, say, motor vehicles, which are outputting all their pollution, right at street levels where people are breathing it. So often air pollution wins out, but the heat can be important as well. The second thing you'll notice, though, is that there's no panel on the left, right? And the reason there's no panel on the left is here's all the different scenarios we ran and analyzed. I'm just showing you a little snapshot. And if you look at 2030 here, which is where I showed the air pollution impacts being really big for particulates and for ozone, you can see that this black is the uncertainty range. You can see that there's no statistically significant signal at all in 2030. And in fact, except for this one really, really high scenario, there's hardly any statistical significance, even by 2050. It really takes a long time for these benefits to become important. So that goes back to kind of that New York Times one, these colleagues that grabbed the data said, okay, let's use the last decade because then we have a big signal. But that's a long time to ask people to wait when you're asking them to take action now. So the other thing we really tried to do in our analysis is this kind of comparison. And I'll spend just a moment here to explain what on earth I'm showing you here, because it's not so immediately obvious. But what it is are several estimates of the cost to the United States to transition to clean energy, to net zero carbon emission by the middle of the century. And so that's all renewable, electricity. It's no more gasoline powered motor vehicles. It's also some changes in agriculture, et cetera. And what this shows is this is the one line, right, where the benefits equal the cost. And this red are the impacts of heat on public health. And so you've got this narrative that you can find in all kinds of policy circles, which is true, that the costs of inaction outweigh the cost of action, right? And that's because this red line here, which is effectively the climate damages, become larger than the cost of mitigation later in the century. I think that is very consistent with lots of publications. But if you add in air pollution, since it kills so many people and since it responds instantly, now you get that the benefits outweigh the costs by this decade. So one of the things I'm excited about is I think this, when I've presented these kind of results initially to some people, is this really resonates with people who think like, I'm really uncomfortable with changing everything now and then I won't see anything even for decades. You know, I care about my grandchildren or my children, but I don't care that much to change my behavior today. This shows that there's actually benefits today, as well as these really important long-term climate benefits. And the last thing I want to show you here is that since we have these state level results, right, this is a global picture, sorry, a national picture here. And so nationally, yeah, air pollution is more important than heat, at least for the next 40 years or so. Eventually, climate dominates over pollution. But even in the short term, you know, it depends on where you live. And so this shows which is the most important public health benefit from aggressively mitigating climate change. In 2030 on the left, and you can see it's either fine particulate, where it's dark blue, or ozone in the states where it's light blue, mostly the Mountain West, but a couple states down here too. By the time you get out to 2070, there's a bunch of the country that has heat as the most important public health benefit. But it also underlines the argument that, you know, it's hard to sell climate action on health benefits of climate directly in the near term, because you can see that that's not a single state has heat as the number one thing by 2030, but quite a lot by 2070. So, you know, I think the overall picture here, kind of summing it up, the way I think of it, bad news, climate action really yields little in the near term from climate itself. It's just a slow system, right? It's like, you know, this analogy, you have to, if you want to turn an oil tanker, you have to turn early, right? Start well before you want it to turn, right? We have to act now, but we're not going to see those benefits right away. But we do get a lot of benefits quickly, mostly from air pollution. And that's helpful because people, you know, economists in particular, but also the general public making decisions about, you know, retirement and credit cards and what to buy at the grocery store, right? We prize near term. They're also, the public health ones are much larger than we thought because epidemiology has been updated recently, and we see that the effects are bigger than in earlier generations of analyses. The other nice thing about air pollution is we control our destiny much more. And it's in our paper, but about 2/3 of those benefits are from US policy. Climate really requires global policy, right? We've all suffered from greenhouse gases emitted anywhere in the world, but air pollution is much more in our own hands. And there's a lot of the benefits that we can quantify. You know, there are things like sea level rise, which are super important, but harder to put a price on. But health and other economic benefits, things like labor productivity, crop yields, et cetera, we can evaluate all of those things and make it really resonant for people. And our web page down there, since it's being recorded, you can go back and look at that. We've put all of those state level results online without a lot of documentation since the paper's not there yet, but that will hopefully arrive soon. But that might be of use to people like you in the Citizens Climate Lobby. So I hope that wasn't too much of a blur of lots and lots of information compressed into 15 minutes. I'm sure it was, but that's what I'm trained to do as a professor. So I apologize if that was a lot, and hope we can now have a take some questions and have some discussion about some of those things. So thanks very much. Back over to either tomorrow or Dana. I'm not quite sure, but Dana maybe.
Yeah, thanks, Drew. That was really interesting. I'm going to take advantage of my position and ask you a few questions I've got from your slides, if that's okay. So the earlier one where you showed the state by state avoided premature deaths, I noticed California was the largest one, which I'm sure a lot of it is because it has the biggest population, but that caught my eye because I'm from California, so that's of interest to me personally. So California's got relatively clean electricity, so is a lot of that avoided premature deaths from transportation, cleaning up the transportation from cars?
Yeah, transportation is definitely number one in California. And transportation just is often number one simply because the pollution sources are right where the people are, right? Where power plants, you often shove off somewhere a little bit away from where people live. And you have a tall smokestack designed to get the pollution away from ground level so people don't breathe it as much. But cars, by definition, right where people are and right at the same level.
That's really interesting. And then the next slide, you were basically converting those avoided premature deaths to like a cost benefit ratio. So is that mostly translating the avoided deaths to a dollar using like the value of a statistical life, or does that also include like avoided hospitalizations and lost work days and things like that?
So in the paper, we quantify all of those separately, and on the website, you can get the value for any of those things. It tends to be that the value of a statistical life of, avoided premature death is so large that it dominates over all of the others. But, I'm glad you raised that because the others are really different from an economic point of view. I mean, the value of from an economic point of view, you get all these terrible things like, oh, an old person isn't worth anything because they're not even working, right? But you can see that there's, maybe a real possibility of bringing certain constituencies a little bit more on board, like the labor productivity losses, from heat. Those are really focused on industries that can't be air conditioned and are in hot places. So, you can really find that the values may not be all that important at the global scale, but if you're working in construction in Texas or Arizona or something, these are really some pretty big numbers. Yeah,
that's interesting. This is something I've always had a little bit of a difficult time with because we're the benefit of reducing air pollution and climate change, long climate change, is that we're preventing these health impacts of premature deaths, and it would be nice if that was enough, but we have to do these cost benefit analyses and try to translate saved lives and prevented premature deaths to a dollar figure, and so that's kind of an ethically difficult thing to do, and I wish it'd just be enough to say, look, we're saving all these lives, so it's worth it, but then because we're a capitalist society, we have to put it into dollar numbers to see if it's financially and economically worth it. So that's always been kind of a thing that I found a little ethically difficult to deal with.
Yeah, I agree. I mean, it shouldn't really be the way, you decide whether this is a sensible thing to do, right? And there are all these weird things about, in the far future, we don't care as much. But even if you don't care as much because the value of money is less in the distant future, what if Greenland melts and, we lose Miami and New York City and Los Angeles, San Francisco, right? What's that worth? It's not even something you can really put a number on very, very easily. But I do think that, we in our work, we try to quantify, for example, the loss to wheat farmers, the loss to construction companies, specific sectors where I don't think it should be part of the, the general way that the American public, say, makes up their mind whether climate is important, but it might help bring along a couple additional parts of society that might be motivated purely by that argument about their own financial impacts.
Yeah, for sure. Okay, I've probably taken enough time myself, so we should go to the poll EV. Tamara, if you could pull that up.
I will share that. And Drew, Dr. Shindell, sorry if while I'm sharing that, If you'd be willing to add that link to the study, I went to look for it in the slide deck, but I'm not finding it. People are asking for that link. That would be wonderful. So let me go ahead and share my screen here. All right, Dana, are you seeing my Poly deck? Yeah. All right, here we go. So let's go ahead and start with Dana. You want to read these off?
Sure, yeah. And then just as a reminder, everybody to either ask a question or to vote up or down questions that you want Dr. Shindell to ask. You go to the link at the top, polyv.com/CCL123, and then you can kind of either enter your own question or vote up or down the other questions that you think should be top priorities for us to ask Dr. Shindell. So the first one we got is, what do you think is the strongest point to make to our senators and representatives? I guess to convince them to take action on climate change.
Yeah, that I would say is, how many are there? 400 and something? You might almost have 400 different answers, you know. I'm not trying to evade the question, but I think there really are very different motivations for different groups. You know, if you take the senators, right, which state they're from and what industries they have is really going to be quite different. You know, you have places that the hardest ones are places, of course, that have a large fossil fuel industry, right? You're going to have a hard time convincing Wyoming and Texas and Oklahoma representatives that this is financially in their best interest, or that health trumps jobs, things like that. In many of the blue states, right, not as hard to convince them to take action, but I think, you know, it can be helpful to present things like the public health benefits. One of the things I have found most compelling, and it's sort of interesting because it goes back to the point Dana raised about putting prices on things, is we look at a bunch of the health impacts of, you know, how many people go to the hospital and how many emergency room visits. And one of the things that people seem to really find compelling is how many children end up in the hospital with asthma. It's a next to impossible thing to really put an accurate price on, but it really gets to people's emotions. And it seems in some of the congressional hearings that I've been involved in, that's been more compelling than a lot of the figures about, you know, number of tons of crops lost or people going to the emergency room. It's children, it's the elderly. So I think those help a lot. I think in states with high unemployment, you know, maybe jobs would be important. In states with a lot of agriculture, you know, maybe in Iowa, it's the number for corn yields, which can be pretty important. And maybe even they're already on board because they have a lot of wind, but maybe adding to kind of the rationale for action by showing things like corn change in a place like that would help. If you're in a coastal region, then, you know, maybe you're really interested in how you can reduce sea level rise. And we have some other work about, you know, ways to deal with that. So it's not always going to be health, I wouldn't say, or the economy. In some places, you know, California or maybe much of the West, fires. I think there's a lot to be tailored to the specific, what's it called, the constituency or the area represented by the senator or representative.
Yeah, I mean, here in California, we focus a lot on wildfires and drought because that's really been battering us a lot in recent years. Yeah. Okay, so next question, we got a Duke alumnus in Oregon who's very anxious from the extreme weather this year. Have the extreme temperatures and rains of this year changed anything about the way you analyze this data? I've read that some climate scientists are surprised by how extreme the weather has been this year.
I guess I would say that they haven't really changed our fundamental interpretation of most of the data that we tend to average over fairly long periods. And the formal definition that the World Meteorological Organization uses is climate is a 30-year running average. So 1 year, we've spent a lot of time too having the media say like, oh, this year was cooler than last year. See, that means we're not in a always worsening trend. And like, no, it's just noise from 1 year to the other. So we try to be cautious about these things. I would say that one of the things, and I think there was something on the intro slide about skepticalscience.com and John Cook, who's a great guy. He has done some work where they've gone back and looked at projections from past IPCC reports.
That was me.
Yeah, that was you?
Yeah, I did that for Skeptical Science. Yeah.
Oh, all right. Excellent. Dana, I'm quoting you without knowing that it was you. All right. I saw it in one of John's books or his page. Great. Okay. So that was this idea that, we get a big team together and we take the consensus and we figure out, in some sense our best estimate, but it's also we're cautious, right? And it has to be adopted by everybody. And so it ends up being not quite lowest common denominator, but ends up being kind of conservative. And so this past year, we're just seeing more and more examples of things outpacing our projections and even being, up at the upper end of the range, but outpacing the median and occasionally even outpacing the upper extreme. So I'd say we're not necessarily changing our overall view of this, but it's certainly it's making people in the climate science community, I think, more worried that we have been too cautious and that our projections, that the reality unfolding may continue to outpace our projections more often than go slower than we projected, unfortunately.
Okay. So let's see, next one. We got, why are more people dying in the North US than in the South, where it seems like it would be actually warmer?
Oh, that's a great question, actually. And I'm really glad that somebody asked that, because that leads me to a point that I had intended to make and forgot, which is that there's also some good news about heat, right? So in air pollution, it tends to just be how dirty your air is, right? Which has a lot to do, like we mentioned before, how close you live to a lot of traffic or maybe some industry. Agriculture also creates a fair bit of pollution. With heat, it's not so much directly a function of the temperature, right? And you're probably all familiar with cases like terrible heat wave in Paris and around 15 years ago or so, and lots of people died, maybe 100 died or so. And it was something like, oh my gosh, it was outrageously warm. It was like 100. And you think, okay, doesn't sound that bad, right? Or Chicago, the bad heat wave in the late 1990s in Chicago killed lots of people. And again, it was like 105 or something. But in Phoenix, it's 120 routinely. And down here where I live, right, in North Carolina or in Atlanta, right, in warm places, it's unclear how much is physiological and people's bodies have just adjusted, and how much is behavioral, and people have learned that, hey, when it's hot, you don't run around like normal, and you go to somewhere where there's air conditioning and you drink a lot of water and such. But it does seem that there's very clear medical data saying that the same temperature exposure in a warm southern climate has much less effect than the same temperature up north. So, British Columbia, right, saw a lot of people die from this recent heat wave just this summer. It's because it wasn't hot for, say, the south of the US. It was just something that people are not used to up there. So the good news about that, just to follow up what I said at the very beginning, the nice thing is that unlike air pollution, where there's very little you can do other than try not to breathe it in, wear a mask, I guess, now that we're all gotten used to that as possible. But for heat, there is a lot more you can do. And, the worry is, of course, that people, as it gets warmer, will get more and more air conditioners spreading all around the planet, and they'll use more fossil fuel powered electricity, and it'll sort of exacerbate the problem. But on the positive side, if we could do it properly and provide the kind of adaptation that Southerners have to, say, people in the North, then I think we have much more chance of reducing the health impacts of heat exposure than we do of many other things. And in France, again, I mentioned Paris, this is very bad heat wave in the early 2000s. They did institute a lot of new policies in response to that, like public cooling centers and checking on older people and the kind of things that are more routinely done in a place like, say, Phoenix. And they did have another pretty similar summer heat wave, and the death toll was something like a few percent of what it was the first time around. So you can make a big dent in it. It doesn't mean you can get rid of the problem entirely, but you can get cold places to be less susceptible, like their southern counterparts.
Yeah, that's really interesting. Actually, I just wrote an article on the Pacific Northwest heat wave for Yale Climate Connections. I'm going to pop a link in the chat here. And I led with a quote from the 2001 third IPC report that basically said that the areas in more temperate regions are going to be more vulnerable to deaths from heat waves, but for this exact reason, because they don't have sort of the infrastructure to be prepared for extreme heat, like air conditioners and other mitigative factors. And so they kind of predicted exactly what was going to happen 20 years ago, which I thought was really interesting. Let's see, I'm going to pull a question from the chat from Tamara's suggestion. It's a good suggestion. From Jim Danforth: how do floods and sea level rise, like storm surge, relate to lives lost compared to heat and pollution?
How do they,
like which cause more mortality, is like floods and heat wave, or floods and sea level rise,
right,
heat wave pollution.
Right. So currently, air pollution is by far the largest, and that's even more true around on a global level, because a lot of countries have really dirty air, and it kills many millions of people every year worldwide. But even for the United States, there's the air pollution would be number one. It's the leading cause for environmental. Heat is thought to be currently second, and is the largest of the things that are really directly influenced by climate. And so fires, of course, very damaging. Fires also contribute to air pollution, which then becomes a little more complicated to figure out what somebody's talking about when they say fires. People actually being burned or people dying from the air pollution from fires. But that one, some of these things are just not as well quantified, because we don't have the medical data that's quite as clear on short-term exposure. Right? If you live in on downtown where there's big traffic, lots of traffic and a big highway nearby or something, right? There's always cars, you're exposed all year round, and that's the kind of data we know that air pollution kills people. From fires, if you breathe a lot of smoke, but it's just for 2 weeks, not quite as clear. But the other things like floods and fires and hurricanes and all of those tend to be small compared to heat. Yeah.
So actually, relatedly, I often hear the argument from kind of contrarian people that cold kills more people than heat. And so the implication is that if we get warming, we're going to get fewer cold deaths, and it's going to more than offset the number of increased heat deaths. Do you have a response to that?
Yeah, so there are several studies that look at that, and there's a nice new one there's a group in Chicago from Michael Greenstone, that's this climate impacts lab, And they have looked at cold and heat, and they do find that cold deaths go down, but heat deaths go up more strongly than cold go down. The other thing that I have found, and the reason that I don't include cold when I look at these health analysis, is heat is really clear. And if somebody, you look at the medical data, and essentially, people don't record heat stroke is sometimes recorded, but it's often not recorded, right? And it's just people died from, some other cause, but you have temperature data, and heat kills people like in a day, or maybe, there's a week lag or something, but it's really strongly correlated with these high heat waves, essentially. Cold tends to be much more seasonal, and the deaths are correlated with just a long, cold winter. But a long, cold winter is, of course, also correlated with things like the flu and lots of other things. So a lot of scientists in the health community don't believe that the correlation between cold and deaths is actually, that only a fairly modest fraction of that is probably related to cold itself, and others are things that have the same seasonality. And so that's why it's often left out. It's just much less clear. But if you do include it, it's also smaller.
Okay, that's interesting. Yeah, so just to remind everybody, if you have questions or if you want to vote on the questions that are already up there, you go to pollev.com/CCL123. And then the next question is, what are you seeing on costs related to vector-borne diseases moving from south to north as climate regions shift?
Yeah, so that's something that we have poked around at for a while and have found it to be really complicated. So essentially, I don't have any numbers on that, because we found that's an incredibly difficult problem to address. And just to, I won't go into it at great length, but there are a couple, there are some studies that do that, and they just tend to say, oh, well, we'll just move this latitude, 2 degrees north, and we'll move that rate, as climate warms, we'll apply the rate there to further north. But if you try to actually model how the mosquito population might move, or some other vector, then it gets really, really, really difficult, because it's really a strong function of how water accumulates. And so, when you look at data sets, you'll find, oh yes, the mosquitoes moved really rapidly in this part of Africa as the temperatures went up. And then you look at another part where temperatures went up just the same, and they find they didn't move at all. And it's because one area, people tend to like throw their tires by the side of the road, and so water pools in them, and there's all these great breeding grounds, and another doesn't. And you think like, I can't possibly model that. That's just far too complicated to know what people would do. Or people have bad sanitation, and so there's lots of standing water that's sewage, and so there's lots of places for the vectors to move. The other thing, which is again kind of slightly encouraging, is like heat, there's a lot you can do about this one. And one of the things that we first tried to do was look at studies to see if you could, like the way we do with a climate model, did it capture the past reasonably well? So let's look at the past in the United States, and let's look at our history and see if we can model how mosquitoes moved over time and vector-borne diseases moved. And it turns out that almost all of the trends are dominated by when people started using screens and things like that. And they have very little to do with climate. So I would say that's a nice thing about this, is we can deal with this problem, at least more so than some other problems like sea level rise, right? Where you don't have a lot of control, or fires, which are really difficult to deal with. But the estimates I've seen, this is still very small compared to heat, and we don't have a lot of confidence in our ability to project it into the future, unfortunately. Maybe someday.
Okay. Next question might be a little tricky. They're asking why Louisiana isn't as warm as some of the other southern states. Do you happen to know an answer to that?
Is Louisiana not as warm? That's interesting. I've only been to a couple times to visit New Orleans, and maybe I had bad luck because I remember it being pretty warm. But maybe I think that was before I'd moved down to the south myself, so I thought the whole south was really warm back then.
I've got a related question. So I've heard there's sort of a warming hole in the southern states where they're not seeing the same warming trend that most of the world really, and most of the other states are seeing. Am I correct about that? And do we know what the reason is for that?
So there has been, yeah, rather than the base temperature, the trend,
Right.
yeah, has been weaker in some parts of the central and southern United States. And that's not been, it's not really all that clear why there's that warming hole. Yeah, I don't think people have looked at that and tried to figure it out, but I would say there's several competing explanations out there, and hasn't really been fully resolved. I mean, it sticks out in the ocean, which helps keep it, a little bit cooler in the summer, but I'm not sure if its base temperature is all that different.
Right. Okay. Interesting question here. What's been the biggest obstacle you've had to overcome in doing your research?
Well, I would say that in the kind of research that I've been doing and talking to you about this evening, an obstacle has been that it doesn't really fit neatly into many of the traditional categories that the government funds research in. And so I worked for a long time at NASA, as Tamara mentioned at the beginning, and NASA is, it's the point of NASA, in addition to space exploration and such, is science, physical science about the Earth and things like that. And so when I got really interested, like I was explaining at the beginning, how do I provide something that's more tangible to people and stuff they can relate to, like their health impacts, then the people at headquarters were like, what are you doing? You're not supposed to do medical stuff. We don't do that as a NASA. We don't do these things. And so I thought, oh, well, I'll apply to, EPA or some other group for funding instead. But they have, they do like air pollution. There's a division that does air pollution, but they don't do climate. And then there's a part of NOAA and NSF that do climate, and they don't do air pollution. And so this kind of spans a bunch of traditional categories. And so I'd say one of the biggest obstacles has been, it's been really hard to get funding to support like building a research team that's kind of transdisciplinary, because the economic grants, they don't do the physical science, and the physical science don't do the economics, and neither of those two do the medical. So the nice thing has been, since I moved to the university, that a large team of students have been really helpful, and I should really thank them, because loads of the work that I even showed you tonight and that I've been publishing over the past few years has all been done by some, bright volunteer undergrads from Duke. So that's been the only way to overcome this.
So was your shift to Duke, did that have something to do with trying to do more interdisciplinary research, or was that just shift for a different reason?
That was really the key driver. I wanted to do stuff that would be interdisciplinary and stuff that I could really take to policy makers, and to even work with policymakers and other parts of the government and UN agencies and things like that, which is very difficult to do as a federal employee.
Cool. Okay. We have a question asking if you could repeat which different health impacts are included in your cost benefit analysis in your research.
Sure. So the one I showed on the screen during my little introduction was just the mortality benefits. The cost was the expenditures by industry on the transition to clean energy. In our paper and on that website that I put the link into the chat, so you should be able to look at that. Then we have a lot of additional benefits, and those include the benefits for avoided agricultural losses for several crops where we have good data. They include hospitalizations for respiratory and cardiovascular diseases from air pollution. They include lost labor productivity due to both heat and air pollution. And they include emergency room visits and medical expending related to health impacts. They also include in the paper, we try to use a not very widespread in public discourse, but long used in the US government, what's called a social cost of carbon, which is kind of a number per ton that tries to include everything related to climate. So that includes storms and floods and droughts and sea level rise and everything. So just for context, we also include that really broad measure. So yeah, that's what's in there. There are no things like biodiversity. There are no things like cultural heritage from stuff getting wiped out from storms or flooding. So there's still it's always quite limited in terms of the benefits, whereas the costs are unfortunately much easier to quantify. So it's a little bit of a apples orange comparison.
Yeah. For the social cost of carbon, do you use something like $50 a ton in that ballpark?
Yeah.
Okay. And so, yeah, I guess that's like the current federal estimate, but as I understand it, they're working on updating that. So that'll be interesting to see what revised number they come up with.
Right. And one of the things that, the past administration did was to try to play around with the way that was calculated and say, oh, we only care about benefits in our country. And we really don't care about the future very much. So they managed to essentially change the formula and drop it down to less than $10 a ton.
Right.
Whereas that's another nice thing about including air pollution. It's less susceptible to that kind of chicanery of like fooling around with the formula, right? Because most of the air pollution is here, and most of it is it's domestic and it's rapid, so you can't mess around with it quite so much. But yeah, that's the current number is around 50 for the US government, and the current price in the European Union is around 50 euros or something somewhat by coincidence.
Okay, next question. Since a warming climate will mean more time indoors, do you plan to do research on the cost effects of air quality indoors, like workplaces, office spaces, and home spaces?
That's an interesting idea. I wonder if the climate or lifestyle ends up influencing how much time we spend indoors more. Yeah, I had not thought of that, and I think I will ponder that a little bit. I've done a little bit of research on the impact of indoor air quality in developing countries where people still burn, say, traditional biofuels, and their indoor air quality is terrible, and is especially bad for women and children, who are usually the ones over these kind of fairly primitive cooking fires and estimated to kill millions. In countries like the US, that's a really interesting idea. So I guess my answer is I didn't plan to do any research on that, but now that you mentioned it, it's definitely worth thinking about. Yeah.
Yeah, it might be interesting to look at the difference between like indoor air quality for a home that's got a gas burning stove versus an electric stove. Or like here in California, we always have to worry about smoke infiltration indoors, and that affecting our indoor air quality.
Right.
Wildfires get worse. So
yeah, that's a good point too, about electrification of more home appliances. Things like furnaces and gas stoves and such will push you the other way and clean up air quality indoors, but you might be spending more time. And yeah, really interesting competing things. Not obvious which way that'll go.
okay, are you getting much engagement from policymakers? Has that been increasing? And then maybe you can take this opportunity to tell us about your congressional testimony and what that was like.
Sure, yeah, and that's been the main format for this, because the main outreach thus far, because I had been in touch with as a congressional committee, actually about a different topic. And then when we were chatting, we were talking about something else, which was kind of the same general thing, but it was a different study and related to air quality and climate and how these were, going in the same direction, and we could use that. And it just kind of, I brought up to them some of the material that obviously had not yet been published because it's still not published. And so it was really unusual to go talk about it before the paper came out, but it just seemed so on point for what they wanted to do, that I went ahead and did that last summer, and we had a hearing and I testified about the national impacts. What I hadn't had time to do yet was to compare with other models that are out there from the IPCC assessment, because as I mentioned, we used the NASA one that we'd run for the IPCC anyway. So there were others and we could put it in context. And that I didn't have time to do, is why the paper kind of dragged on for a while afterwards. But what was really nice about that was the testimony. I didn't really have time to talk about any details too much, and certainly not state level. But then we were able to work, the oversight committee sort of arrange different delegations from different states who were interested in preparing state level reports. And so since we had done all the state level analysis, we were able to work with, the Florida congressional delegation and California and Wisconsin and Utah and a whole bunch of states. I think in the end, we had put together 12 different reports for congressional delegations from the states. And they seem to feel that it was useful. I hope that's correct. One thing that was nice was that congressional testimony is far off in Washington and might make a little news somewhere, and interested people might hear about it. But when the congressional delegations released their local reports, they tended to get picked up in the local media, right? So if it's a Florida report, then it's covered in, the Orlando Sentinel and the Miami Herald, which might never pick up the national story, but do pick up the local one. And those might be more influential. So I think that's been, it's been much more successful in getting the story out into the media and into the policy sphere than virtually anything I've ever been involved with. So hopefully, I don't know how much it moved the needle on any of this, but I've certainly been very pleased. And some other work I've been involved in recently has been on the public health benefits of reducing methane. And we've done similar type of outreach and made a similar type of website. And that also, it seems that has helped turn the conversation from a purely climate focused one to a kind of a more multifaceted one that has increased the kind of political will to push for more aggressive policy. So overall, I've found that the general topic of bringing in health alongside climate and bringing in both air pollution and more direct climate environmental health issues has had some resonance, and it's really helped with the policy.
Yeah, I recall from the time that there were a lot of newspaper stories about your testimony, focusing on basically the health impacts from air pollution being twice as much as was previously thought, and that got a lot of media attention and stories. So that was really constructive.
Yeah, it was funny that we got that because we primarily not because we had very different understanding of the pollution levels, but because new medical science had come out and said that the impacts per dose that you breathe in were larger than we thought. And so we're thinking like, are we on shaky ground because this is higher than all of the older work? And then within a month or two of the testimony, some other new studies came out with even higher exposure response results. So I think we're now sort of not even the most extreme ones, but we might be even somewhat low.
Okay, we're getting close to the top of the hour. Tamara, do you have any closing remarks that you were going to make?
I do. First of all, I just want to say thank you so much to Dr. Shindell and to you, Dana, for being able to MC and helping us walk through some really interesting and helpful science information, climate science information regarding health. And I am going to share this slide. If I can talk and chew gum at the same time, then I'm going to show you this thank you slide so that you will know how grateful we are that you are here this evening. To all of you, tonight's recording is cclusa.org/YouTube. And you can also, if you're interested, if you're not currently a member of CCL, feel free to join the organization. It costs you nothing, but you get a lot. So cclusa.org/join. Should you have any interest in skeptical science, the website is there, as well as Dr. Shindell's website at Duke. And we have a forum. Well, actually, I should say first, we have a training that you can, goes into the basics of climate science. It's an interactive training. There's some really cool things that move around the screen and you can drag them and drop them. Climate science basics, and that is on community. You can just search climate science basics in the search bar, or you can type in that very long URL there. And I just want to thank everybody for being here. Again, Dr. Shindell, Dr. Drew, and Dana, thank you very much. And have a wonderful evening, everybody. Thanks for being here. Good night.
Thanks for having me.
Thanks, Drew. That was great.